I'm Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. I have many requests regarding equivalent trigonometric functions. In this particular video, with the help of 4 examples shown before you, we are going to understand complete concept of relating trigonometric ratios. You can go through these questions, answer them, and then look into my suggestions. Now the questions are type, given that cos of 3 pi by 10 equals to sine y, first express 3 pi by 10 as difference of pi by 2 and an angle theta, and then apply a cofunction identity to determine the measure of an angle y. So in this particular case, we have to apply the cofunction identity to find the angle y so that cos of 3 pi by 10 is equal to sine y. And as the question suggests, you could do this if you could relate 3 pi by 10 as a difference of pi by 2 and an angle theta. So that is the key. How do we relate these two things? That is what we are going to see in this particular video. Now, the last question is kind of, given that minus secant theta is cosecant 1.25, all the measurements of angles in radians, and I should write that angle theta lies in the second quadrant, determine the measure of theta to 2 decimal places. So these are the type of questions which we are going to answer in this particular video. Let's begin with their solution. I'll go through the basic concept just to remind you what you really know. You know SOHCAHTOA, the ratios of sine, cosine, and tan. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. So in this particular triangle, which is a right angle triangle, let me ask you, we know sine A is what? Well, here we'll see the sine of A is equal to the side CB over AC, or we can write BC over AC, correct? Now, if I look from the other angle, which is angle C, in that case, what is cos of C equals to? Well, cos of C will be the adjacent side over the hypotenuse, correct? That is cos of C. So that means that is also equal to BC over AC. So you see how sine A and cos C, they exactly have the same value. These are called cofunction identities. And the reason is that, after all, angle C is what? Angle C is pi by 2 minus angle A. So when you relate inner right angle triangles, the angles, then we get cofunction identities. That is the concept. So I hope this is absolutely clear. Now it happens that tan will be related with cotangent, right? And their reciprocal ratios will also be related. So that gives you the set of formulae written here, which is cos of pi by 2 minus theta is sine theta, cos of pi by 2 plus theta will be minus sine theta. Why? Well, pi by 2 plus theta brings us to quadrant 2. And now, you look at the cast rule. We know in quadrant 2, only sine is positive. Well, all are positive in quadrant 1. In quadrant 2, only sine is positive. Tan is positive in quadrant 3, cosine in quadrant 4. So when I talk about cos of pi by 2 plus theta, cos is negative and therefore we have negative sine theta. The cofunctionality is true, but the sign changes to negative since we are in quadrant 2. Similarly, if I take sine of pi by 2 minus theta, we are in quadrant 1, everything is positive, sine becomes cosine. Perfect. However, sine of pi by 2 plus theta is again equal to plus because sine is positive in quadrant 2. So I hope that makes sense. So what we have done is we have related the angles of angle values of trigonometric ratios, sine with cosine, cosine with sine, tan with cotangent, secant with cosecant, and so on. These are called the cofunction identities. Perfect. So we'll explore them with our examples now. Also important is to understand the principal and the related acute angles. Well, when we say related acute angle, it means we're talking about angle made with horizontal line, right? So let me say related acute angle. Let me say alpha is my related acute angle. So alpha is angle with horizontal. As you know, sine and cosine will have multiple values being periodic. However, a calculator only gives you one value. So what we do really is that we look at this related acute angle, let's say alpha, and let's say we are working with sine theta equals to half. In that case, and we want to find the value of theta within the interval, let us say 0 to 2 pi. Now, we know there are two values, sine is positive, so we are looking for a value in quadrant 1 as well as in quadrant 2. How do we find the other value? Well, it is using the principal angle and the acute angle, related acute angle relation. So we know this angle should be the answer, which is the related acute angle alpha. Angles with the horizontal, it keeps the ratios exactly same in magnitude. The value could be positive or negative depending on the quadrant. Now, how much is this angle? Well, clearly, this angle is pi minus alpha, correct? So, whenever it is pi minus alpha or pi plus alpha, sine remains sine, cos remains cos, tan remains tan. However, we could have negative or positive values as shown in the first three rows. Perfect. So these give you relation between the principal and the related acute angle, which you have already worked with while solving equations. Perfect. So I hope you remember this. With that in mind, let's see how do we uh, solve these questions. Once again, a reminder of the cofunction identity, since most of the time this is the point which is not very clear to most of the students. And that is why I've got so many questions based on this particular topic. So once again, if sine theta is y, so what I'm doing here is that I've taken a unit circle. So what you see here is a unit circle. Now in this unit circle, if my point is x and y, then clearly the cos of theta is x and sine of theta is y, correct? So we are writing sine theta as y, which means y over 1, right? You can see that if I relate it with the angle at the point P, which is pi by 2 minus theta, then y is adjacent side for the given angle. And therefore, it is cos of pi by 2 minus theta. Do you see the cofunction identity? So sine theta is same as cos of pi by 2 minus theta. Similarly, cos theta is same as sine of pi by 2 minus theta. Tan theta is same as cot of pi by 2 minus theta. So when you look from the other angle, which is pi by 2 minus theta, the side which was earlier opposite becomes the adjacent. And that leads to the cofunction identities, correct? Now let's solve these questions one by one. And I'll share with you a very simple strategy to solve. You don't have to remember all those formulas, 16 of them given in the books. Okay, let's begin with the very first question, which is given that cos of 3 pi by 10 is sine y. So we are given that cos of 3 pi by 10 is equal to sine y. We are given this. Express 3 pi by 10 as difference of pi by 2 and an angle theta. So we have to write 3 pi by 10 as a difference of pi by 2 and an angle theta. This is what we have to write, correct? So how do we get the angle theta here? Well, let me do this standard way. Bringing theta to this side, we get pi by 2 minus 3 pi by 10. Taking the common denominator as 10, we can write this as 5 pi minus 3 pi. And that gives us 2 pi by 10, correct? So that gives you the value of theta, which is shown here. Perfect. So this is what we will normally do. So I'll call this as a standard way of doing it. Now it says, and then apply a cofunction identity to determine the measure of angle y. So basically, after doing this, you can get the cofunction identity. How? Well, you know that we have written this as something like this. Cos of 3 pi by 10 is equal to cos of pi by 2 minus 2 pi by 10. You get the idea. And now, using the cofunction identity, we can write this as sine of 2 pi by 10. Now, we are given this is equal to sine y, and therefore, we know y is equal to 2 pi by 10. Is that clear to you? So that is how you will be solving such a question. Now, this involves a lot of calculations as we have shown here. I will show you another method of doing this, and that is where things become very interesting. So let me show you another method of doing this now. So I've taken a fresh page to explain you the concept of doing the same question which we just did with a lot of algebraic equations, I should say, right? So basically, what are we given? We are given cos of 3 pi by 10 is equal to sine y. Now let's see what is 3 pi by 10. So we know in a coordinate plane this is 0 and that is pi. I am dividing this pi into 10 equal parts. That means 5 here. So 1 pi by 10, 2 pi by 10, 3, 4 and 5. So this is pi by 10, 2 pi by 10, 3 pi by 10, 4 pi by 10 and 5 pi by 10. Do you see that? So that is what is meaning of 3 pi by 10. Basically, we are looking into this angle, 3 pi by 10, correct? Now you can clearly see from here that we wanted to find a relation between 3 pi by 10 as the difference of pi by 2 and the angle theta, correct? So this is the angle theta for us. Correct? How can you write this as a difference? Well, clearly that is pi by 2, right? And what we have to take away from this? 1 and 2 pi by 10, correct? So from here directly, we know that we could have written 3 pi by 10 as pi by 2 minus 2 pi by 10. Do you see that? So if I do pi by 2 minus 2 pi by 10, we get 3 pi by 10 as shown here. So that is one way of relating, doing this first part, correct? Here is the alternate method. Alternate method is cos of 3 pi by 10 is equal to cos of, we want 3, and we know half of 10 is 5. So it is 5 pi minus 2 pi over 10, correct? Do you see that? So what is half of 10? Half of 10 is 5. We want it as a difference of pi by 2 and some angle, and directly we get 5 pi minus 2 pi is 3 pi, correct? And so we could now write this as cos of, individually if you think about it, it is 5 pi by 10 minus 2 pi by 10, correct? Which is cos of pi by 2 minus 2 pi by 10. I am doing all these steps to make you understand how easily we could do this question without getting into the steps which we did earlier. Remember all this, correct? So directly we have written this. I'll show. So do you see now how easy it is? Once you write this as cos of pi by 2 minus some other angle, we could easily write this as sine using cofunction identity. That is what is cofunction identity, right? And therefore, we can conclude that y is equal to 2 pi by 10. Is that clear to you? Do you see how easily we have done it? Have a good look at this particular page to understand the concept and then relate what we did earlier and how we got our answer. Perfect. So these are different strategies to work with. We'll again apply this strategy in another question. Here is question number 2 for you. I'd like you to pause the video, answer this question, and then again look into my suggestions. So this time the question is, given that cot 13 pi by 18 equals to minus tan y, first express 3 pi by 10 as sum of pi by 2 and an angle theta, and then apply a cofunction identity to determine the measure of angle y. Very similar question. How are we going to approach this time? Well, we'll use our strategy. When I'm saying 13 pi by 18, it really means what? It means we have divided the pi into 18 equal parts. So this is 18 over 18 pi, correct? That should be 9 over 18 pi. That is pi by 2, right? So we have 10, 11, 12, 13, 14, 15 like this, right? So 13 out of 18 means something like here will be 13, right? This will be 13 pi by 18. Is that clear to you? So when you do 13, then how far have you come from 9? 9 plus 4, right? So this is 4 pi by 18. Does it make sense to you? Do you see the difference directly? How much should I add to 9 to get 13? I should add 4, right? So, look here. I can write down cot of 13 pi by 18 as equal to cotangent of pi by 2, which is same as 9 pi by 18. Or let me write 9 pi by 18. Right? I'll keep this common denominator as 12. So I have 9 pi plus 4 pi. Does it make sense to you? 13 pi is 9 pi plus 4 pi. And by 18, sorry. Denominator being 18. 9 is half of 18. And therefore, I could now write this as equal to cot of 9 pi by 18. 18 pi, sorry. Oh, sorry, 18 is okay. 18, right? plus 4 pi by 18, right. Now that is cot of pi by 2 plus, you can simplify this also. We get 2 pi by 9. Is that clear to you? Now since you are in quadrant 2, apply the cast rule. Cotangent has to be negative, and therefore we write negative here. As a cofunction identity, we get tan of 2 pi by 9. Do you see that? And therefore, if this is equal to minus tan y, we have y equals to 2 pi by 9. Is that clear to you? It is as simple as that. That is how you could do it. Have a good look at it, what we did. We wanted to get to the angle 13 pi by 18. Half of 18 is 9. 9 plus 4 is 13. Do you see that? 9 plus 4 is 13. And so we could write 13 pi by 18 as 9 pi plus 4 pi divided by 18, which is same as pi by 2 plus 2 pi by 9. After simplification, you saw it. And so using the cofunction identity, we get our result. Is that clear to you? Now take up question number 3. It says given that cos of 3 pi by 11 is 0.6549, use equivalent trigonometric expressions to evaluate sine of 17 pi by 22 to 4 decimal places. So basically in this question we are given that cos of 3 pi by 11 is equal to 0.6549, correct? And what do we need to do? We need to find the value of sine of 17 pi by 11. That is what we need to find to 4 decimal places. That becomes our question. 17 pi by 22, sorry, not 11, 22. That is what we need to find. So how can we do that? Well, since the denominators are different, what I will do here is I'll write this cosine ratio as cos of 6 pi multiplying both numerator and denominator by 2 and saying what we are given really is cos of 6 pi by 22 as 0.6549. That is what we are given as. We want to find sine. That means we have to write this as pi by 2 plus theta, right? So to figure this out, I can actually write this as sine of 17 pi by 22. So the number 17, what is half of 22? So what is half of 22? Well, 11 is half of 22. So 11 pi plus 6 pi, do you see that? Gives me 17 pi, right? So this is equivalent to sine of 17 pi by 22. Now that gives us sine of 11 pi by 22 plus 6 pi by 22. And that is same as sine of 11 and 22, half, right? So it is pi by 2 plus 6 pi by 22. I could also write this as 3 pi by 11, right? So that is equal to cos of 3 pi by 11. And so it is same as 0.6549. You get the idea. See how I wrote 17 pi as 11 pi plus 6 pi, 11 being half of 22. So we got this as 11 pi by 22, which is pi by 2. As soon as you get pi by 2 plus some angle or minus some angle, you can write sine as cosine. So we wrote this as cos of 6 pi by 22 we could have written, or we got the original 3 pi by 11. The value was given to us, and therefore now we can write down our answer that sine 17 pi by 22 is 0.6549. Does it make sense to you? Simple as that, correct? Sine is positive. Remember this, the cast rule, right? Since sine is positive, we have the positive values. Perfect. That is how we can easily solve. So I hope the concept is absolutely clear. Now let us take up the last question. Here is question number 4. Given that minus secant theta is cosecant 1.25 and theta lies in the second quadrant, determine the measure of angle theta to 2 decimal places. So let me rewrite this as we are given that cosecant 1.25 is basically equal to minus secant theta, right? And we have to find what theta is. So that is the question for you. Now looking back into the cast rule, we understand that all are positive in quadrant 1, sine in 2, tan in 3, cosine in 4. Since we are in quadrant 2, we are also given this is in quadrant 2, right? Second quadrant. So we are working in this quadrant. Now in this quadrant, we know that the secant value will be negative, correct? So we are looking at 1.25 and we are saying what is this equivalent to in secant terms? Well, clearly using the cofunction identity, we can write this as equivalent to minus of secant of pi by 2 plus 1.25. That is what it has to be, right? And we can now calculate this angle and write down the result. So theta basically, so this implies that theta basically is equal to pi by 2 plus 1.25. And now you can add these using the calculator. So pi by 2 plus 1.25 on the calculator gives me 2.820, right? So rounding to 2 decimal places, we get theta as equal to 2.82 radians. Is that clear to you? So that is how we are going to solve this particular question. So basically, you can say 1.25 is some angle here, for example, right? We are looking for the angle in this particular quadrant where this is the angle theta. You get the idea? And that is pi by 2 plus 1.25. Is that clear to you? So that becomes the visual for understanding question number 4's solution. So I hope this is absolutely clear to you. You get it? So just add pi by 2 to 1.25 to get your result. So in this video, we have learned how do we relate the angles so that we get equivalent trigonometric ratios. These are the standard formulae which you have seen in the books, but with the strategies which we have used here using a simple cast rule and the cofunction identity, we can actually solve all these questions. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'll be great. Thanks for your time and all the best.